We don't have like human-sized amoebas walking around. What type of coffee cup would keep your coffee the warmest, the longest? One with a narrower or a wider opening? This is correct, the one with the narrower opening, because there's less surface area for heat to escape. So basically, as wide as this is, that is how much coffee is being exposed to the air. The more that's exposed to the air, the quicker it's going to lose heat to the air, versus the narrower it is, the less quickly it's going to lose heat to the air. You will see a lot of coffee cups, they get smaller as they get towards the bottom, because as you drink it, it decreases the amount of surface area that is exposed to the air, so that if you take a while to drink your coffee, it's not losing more and more heat as it gets lower and lower. If you have a coffee cup like this one that doesn't get very narrow as you go down, or does not narrow at all, as you get towards the bottom, it loses heat quicker. So if you have just a little bit left, that's why it will get cold quicker, because more of the total surface of that coffee is exposed to the air. You know you're a slow coffee drinker, then it is in your best interest to get coffee cups that narrow as it goes toward the bottom. This is also why if you have nachos that are piled up versus nachos that are spread out, the piled up nachos will stay warmer longer. And why if you're cutting meat, if it is uncut, more of that heat is going to stay inside of the meat than versus the pieces that you've cut into smaller pieces, because the smaller the piece that has been cut, the more surface area that has been exposed to the air. So those are all great examples of this surface area phenomenon. You're teaching cell size and helping students to understand why smaller cells work out better for living things. Now for real, the more you know. Stay curious, y'all. See you later.